C language is a general-purpose and structured programming language developed by Dennis Ritchie at AT&T's Bell Laboratories in 1972 in the USA. It is also called a procedural-oriented programming language. C is not specifically designed for specific application areas, but it was well suited for business and scientific applications. It has some various features like control structures, looping statements, arrays, micros required for these applications. The C language has following numerous features as portability, flexibility, effectiveness and efficiency, reliability, interactivity.
Back in 1969, a couple of computer scientists here at Bell Labs started to develop some programs they needed for their own use. What Ken Thompson and Dennis Ritchie started developing then has evolved into the Unix operating system, which by now is widely used around the world.
We were trying to make computing as simple as possible. In the late 1960s, Dennis Ritchie and I realized that the then current operating systems were much too complex. We attempted to reverse this trend by building a small, simple operating system on a mini computer.
Well, what we wanted to preserve was not just a good programming environment in which to do programming, but a system around which a community could form, fellowship. We knew from experience that the essence of communal computing, as supplied by remote access time-sharing systems, is not just to type programs into a terminal instead of a key punch, but to encourage close communication.
The Unix system started out as a two-man effort, and by now it's used all over Bell Labs. We have close to 20,000 computer terminals in this company, roughly one per employee, and most of them are used for communicating with Unix systems. One of the main reasons the Unix system is popular around here is because it provides graceful facilities for decomposing complex computing tasks into simple subtasks.
The Unix operating system is basically made up of three parts. The kernel, or operating system proper, is the part that manages the control of the machine and supervises scheduling of the various user programs. The shell, or which is the name we give to the command interpreter, looks after the communication between the user and the system itself. And the third part, which is actually the largest, is the various utility programs, which perform specific tasks like editing a file, or sorting a bunch of numbers, or making a plot. In other words, all the other programs that are not provided directly as part of the operating system kernel.
A high-level programming language developed by Björn Strostrup at Bell Laboratories, C++ adds oriented features to its predecessor, C. C++ is one of the most popular programming languages for graphical applications, such as those that run in Windows and Macintosh environments.
In the really old days, people had to write their code directly to work on the hardware. They wrote load and store instructions to get stuff in and out of memory, and they played about with bits and bytes and stuff. You could do pretty good work with that, but it was very specialized. Then they figured out that you could build languages fit for humans for specific areas. Like they built Fortran for engineers and scientists, and they built COBOL for businessmen. And then in the mid-60s, a bunch of Norwegians, mostly Ole Johan Dahl and Christian Nygaard, thought, why can't we get a language that sort of is fit for humans for all domains, not just linear algebra and business? And they built something called Simula, and that's where they introduced the class as the thing you have in the program to represent a concept in your application world. So if you're a mathematician, the matrix will become a class. If you're a businessman, a personnel record might become a class. In telecommunications, a dial buffer might become a class. You can represent just about anything as a class. And they went a little bit further and represented relationships between classes. Any hierarchical relationship could be done as a bunch of classes. So you could say that a fire engine is a kind of a truck, which is a kind of a car, which is a kind of a vehicle, and organize things like that. This became known as object-oriented programming, or also in some variants of it as data abstraction. And my idea was very simple: to take the ideas from Simula for general abstraction, for the benefit of sort of humans, representing things so that humans could get it, with low-level stuff, which at that time was the best language for that was C, which was done at Bell Labs by Dennis Ritchie, and take those two ideas and bring them together so that you could do high-level abstraction, but efficiently enough and close enough to the hardware for really demanding computing tasks. And that is where I came in. And so C++ has classes like Simula, but they run as fast as C code, so the combination becomes very useful.